your e+weather data is probably wrong. Well, it's not the weather data itself, it's not the weather data's fault. But imagine you have a project in the city of Rome and you go online and you download the next best e+weather data file you can find. Well, it's at the airport. Normally, a lot of the weather stations are at airports. Now, the problem is the airport is several kilometers outside the city of Rome. And everybody knows that cities build up much more heat than the surrounding landscape. So if you want to be very exact with your weather data, either your project is at the airport or very close to it, or what would be another option? Well, one of the options is to modify the weather data based on assumptions. And one way to do that is with Dragonfly. So with Dragonfly, you can adjust your weather data, or you can modify your weather data to a certain degree based on your model you want to test. And that's what we want to look in this video. Okay, all right, let's examine this a bit more. On the top here is the weather file, or let's say the temperature chart for Rome at the airport. This is the airport data. Of course, the airport is also not the coolest spot either, but there probably is more air movement and so on, and there's the surrounding landscape probably absorbs a bit of the heat. Nevertheless, the lower one is an alternative version of that upper data. As you can see, it has slightly more orangey kind of spaces. Everything is a bit lighter. That means it's a bit warmer, and it tries to simulate how the first weather data set would behave in a more urban setting. I just want to show you how that works, and that's also my intro for the Dragonfly alternative weather portion. This is for me the more interesting part. We will look at the energy portion at some point, but this is very US specific, and I need to really study and learn a bit more about this portion here. We haven't checked the serials yet, but they are very simple. I will just very quickly go through so you understand what's happening. As you remember, we built our Dragonfly script. You just can go back to my previous videos if you haven't watched these and see how we build a model. These are very simple. I haven't applied any materials yet or construction sets, but it was more about how to build a simple model with Dragonfly, and how can we visualize it, and how can we apply windows and louvers and stuff like that. So that's what we looked at. The workflow is very similar to Honeybee, but it allows for different things. For example, the weather data modification, or the alternative weather as it is called here. The serialized portion here is nothing more than conversions. You can basically translate your Dragonfly object to a string, to a JSON text string. You could also then get basically your text string back as a model. Dragonfly dump objects. This is similar. Dragonfly dump Dragonfly into a JSON file, or you reload a Dragonfly object from a JSON file. So it's very similar. I haven't used it yet. This one is just another version of the JSON files. It's basically translates a Dragonfly into an UrbanOpt compatible GeoJSON with linked Honeybee model JSONs. So it's a much more sophisticated version of that JSON file. And then what we already used before was the Dragonfly model to Honeybee. That we used in order to visualize our model. We had our model. This is now just a bunch of extruded boxes just to test the alternative weather file. And then the Dragonfly model from GeoJSON file, so you can create a Dragon model back out of that GeoJSON file you created. For the energy part, you need to install this UrbanOpt CLI component or software, which help to calculate within these tools here. Again, I will not go through this yet. I need much more time to study that a bit better. And again, it's very US focused. Nevertheless, I will for sure will find some time and see how we can go through that. The alternative weather is on the other hand really interesting and useful. It's basically can create a very detailed scenario of your model you're building, and how it kind of influences the microclimate around. So that's the whole point of it, and that allows also for like testing. Do I need more vegetation? Do I need more tree cover? Do I need more green space areas and so on in order to control that heat island effect to a certain degree? Okay, I will just go through. As you can see here, this is the weather data I just showed you. The first version is basically the original data file. The second one is the modified version. And I just tried just with a few parameters. So it's not a perfect version of a weather file which is now absolutely exact what Rome would be in the city center. But it's just gives you an example that there's this possibility to modify and test what my model or my design could have an impact on the surrounding. Okay, how can we do that? I will just basically delete everything I had here so we can start from scratch. Again, this was my model. Don't worry about this. There's only a few windows here. That has nothing really to say. I just wanted to create like a situation, let's say, and I added even a terrain model or just a flat plane, just to test things and to test how the alternative weather works. Dragonfly run urban weather generator. So we need that. That's the first thing we need. And it starts right away. What do we need? We need a model. This is the only drawback. It works with Dragonfly models. You need a Dragonfly model. That's the only drawback, because it would be really interesting to just use a geometry. And then we need a weather file which we want to modify. So I have here already the weather file from Rome. We can just do that whole process again. You can find these tools in Ladybug. Ladybug has the tools for the weather data. Downloader, the search tool, and later we will also need this one, the import e+weather file. I tested Rome already. Maybe let's just take another one. Let's take whatever. Madrid. That could be also interesting, although it's quite in the city. Might not be so different. Valencia. Seville. Let's try that. Copy to clipboard. Okay, it looks like it worked. Plug it in here. If this turns gray, we can know, okay, this weather file has data inside. And then we can plug this also in here. So this is the first start where we can test differences. We actually don't need anything else here in order to run it. We just need a toggle, Boolean toggle. Yes, and we need a write. We need to have a second one to start the writing process. So that will write the file onto your computer, and the second one is to run the whole calculation. And it calculates the whole year. Alright, so that already ran, and we have an alternative weather file. It says here urban e+weather data, or e+w. Okay, so in order to compare, we could now add a chart. Let's just add a chart like the hourly plot, and we can just place the temperature, and we can add a base point, so it doesn't overlap with our model. Just copy this, and we can check if this is very different. Oh yeah, sorry, we still need this tool here. Otherwise that doesn't work, of course, what I just did. So we need to place this here. That's what we want. That's the. I'll just copy this point here. So now you're gonna say, oh, it just looks completely the same. No change whatsoever. Actually, there is a bit of a change. Here's 41 and here's 40 degrees as a maximum. That's why I would encourage always to control your output in terms of the maximum and minimums. So you can compare it really. I take here the legend parameters and I use the same maximum for the temperature. Just putting here 41, that was the maximum, and I'm gonna place that here, legend parameters, and here. still, it's pretty similar. Actually very similar. Now we have a chart from 240. Let's also put the minimum here. It seems like that's needed. Seems like it never goes below 0. Interesting. In Valencia. Oh no, that was Seville, right? Now we have the same range, but you can see it's actually the lower one is more slightly milder, it seems like, or slightly cooler. It has less. It's less red in here, as you can see. That's the reason why is because there are certain default values in that urban alternative weather generator, and we'll look at that in a moment. What else do I want to do before we continue? I want to control the period, because otherwise every time we're gonna plug a new thing, it's gonna recalculate. So I was thinking, okay, let's do that differently. We put here the simulation parameters first. The UWG simulation parameters. These are this one, simulation parameters. Now, if I plug these, it's gonna run again, so I will turn this off. And that has a run period input. I would go here into Ladybug, and we can first of all set an analysis period, and then we can also apply the analysis period. That's how we're gonna do it. So we need a start month, and I can just, what I normally do here now, just put here start month, and I use the same for the end month, so we just get 1 month period. Is from the June, the 1st of June to the 30th of June. That's the period. The others are already set. Oh, actually August. Let's take August, because it seems like August is here the hottest month. So let's take August. That's my period, and then I can add any data. For example, the dry pulp data. This is the temperature, and that can go into here. Now I only see 1 month. I can also place this here, and now it should actually work already. So let's try that. Interestingly, it's recalculated the whole year. So I can just do here the same. I just copy this and get dry pulp temperature here, and we can plug this in here. Alright, so again, not much change. Temperature is the same. It's very similar, if not identical. But now we can add more information. So we can, for example, here in the simulation parameters, we can add a vegetation parameter, the e+weather site, the boundary layer, I think it's boundary layer, boundary parameters. So let's start with that. We can first of all here we can add vegetation parameters. I will not go too much into detail here, but the albedo is basically a number between 0 and 1 to represent the ratio of reflected radiation from vegetated surfaces to incident radiation upon them. There is also the start month of when the vegetation starts to, or when the evapotranspiration begins, probably when the leaves come out, and also end. And it says here that by default it will analyze the e+weather data to see which months are, so it's automatically sets basically the start and end month. So the tree latent basically will give you, again, it's like a number between 0 and 1 and represents the fraction of absorbed solar energy by trees that is given off as latent heat. Currently, this does not affect the moisture balance in the UWG, but it will affect the temperatures. And the same for the grass areas. I would just leave that here. I leave all the default values, and let's see what's happening. There's another object, is the e+weather site. And this can be influenced with this tool here. Dragonfly reference e+weather parameters. I actually forgot again to put here the bifocals. These are always very useful. To just add a label on top, so you know which tools I'm using here. get it out of the way. Here I can put all kinds of things. Obstacle height, a number of that represents the height in meters of objects that obstruct the view to the sky at the weather station. Yeah, interesting. It's a bit difficult probably to determine, but these are quite interesting. The vegetation cover is interesting. A number between 0 and 1 that represents the fraction of reference e+weather site that is covered in grass. And so you can be very specific of a number that represents the height in meters at which the temperature is measured on the weather station. The default is 10 meters, which is the standard measure height. And the same for the wind measurement. Where's the wind, in which altitude is the wind measured? And it seems like 10 meters is kind of a standard. I will also not change here much, but we will play a bit with that vegetation cover. And I can add here, probably can play with the vegetation cover a bit. That's something I could, you could figure out how does that work at the site you are planning your project. Let's try here 0.1. Again, seems like it has not much influence. We can also we could average the data to see if there's any difference. Oh, we also need to separate the data from the headers so we can understand what's the difference here. Put this in here. So the average temperature is 26. It's quite hot. Yeah, it's slightly different. It's slightly hotter here in this scenario. Not a lot though. It's just very tiny differences. So it would be now, for example, interesting if it changes a lot. If I add more vegetation. Let's go here to 0.99 and let's see if there's a difference here then now in this number here. Not a lot, not really. But that also depends a bit. I mean, at the moment we're only testing only 1 month. So we probably need a bit more data to see like a big difference. Let's put it here so we can see actually exactly what's happening. Yeah, it changes very slightly. Interestingly, it's overall cooler with less vegetation cover. But let's see. Let's continue here. There could be quite loads of difference in other months, and it's really just to show you what's possible here. Okay, we have with the albedo we have the start month, the end month, the tree latent, the grass latent. This is about how it's basically absorbs and gives back heat to the environment. We can influence the vegetation cover, obstacle heights if known, temperature height, where on which level is the temperature measured, and the wind, where is it measured again. We can also change the model so that the model has more influence on this whole weather generator. So it's either you're using a building as your input or you're using a model. In my case, we have a whole model with several buildings. So we can use this here. We can place our model. So that allows for several other things to be considered. For example, the terrain, traffic, tree cover, grass cover. Just to be very clear, why do we have tree cover, grass cover twice? This is basically the reference weather data. That's the reference site, which is the airport. That's actually at the weather station. So we try to improve the weather data. So it's basically trying to understand first what are the parameters of the original weather data. That's what we input here. As you can read here, it's the e+ site, the reference e+ site object to specify the properties of the reference site where the input rural e+weather was recorded. If none, generic airport properties will be generated. So it really tries to understand where does the weather data come from, what are the parameters at the site, and how could that translate to the site we're testing. So that's very important to understand. So that's why we have the vegetation cover twice. I could say now, okay, my vegetation cover at the airport where the weather station is actually 0.5. And The obstacle could be, for example, a building. Maybe there's a building next to it, and so on. And now we can adjust our model. We can add more stuff to the model too. The terrain, that's quite interesting. So we can add a terrain here. The terrain has not just the geometry. Actually, I need to create a geometry here. I need to input a geometry. This is, in my case here, just a very simple surface. But that could be also different. So I just generated this, I just created this surface which I'm using. But of course it could be also slope, or it could be also larger. I guess the more buildings and the more accurate your surrounding is modeled, the better probably. Put this in here. So that's my terrain geometry. Here again, the albedo, it's like how much is the surface reflecting the pavement. There's like a typical, or the default is 0.1, the typical fresh asphalt. And let's see, is there a big difference here? Probably not that much, but we can have a look here at the output, the average temperature. Yeah, it's a bit hot. We can also here adjust the thickness of the pavement material. The default is 0.5 meters, conductivity, and volume heat cap. Whatever that means. A number representing the volumetric heat capacity of the pavement material. So that gets very scientific. Please feel free to research and check out what that is. I will not touch it. It's just I will just show you how you can add these parameters to your model. There's a traffic input. That's quite interesting. So we can get this tool here. It's called Dragonfly traffic parameters. That can be placed in here, and here I can just you can specify watts per area per square meter, and it also has a description of what it does. A number representing the maximum sensible anthropogenic heat flux of the urban area in watts per square meter. This is specifically the heat that does not originate from buildings and mostly includes heat from automobile street lights or street lighting and human metabolism. If auto calculate, it will be estimated from the average building story count of the model hosting the traffic parameters. A typical downtown area would be 20 watt per square meter. Let's assume we are downtown. Actually should rerun. Oh, my bad, I haven't really attached this. So the output of course need to be, that's why I was like wondering, there's no change to the model. No, the output of course need to be placed in here. Let's do that. Alright, so now I have my modified terrain model in here, and let's see difference. Yeah, it's just changed slightly, not really a lot. That's quite interesting. Let's put this to a maximum. I'm curious what's happening. Not much difference. Yeah, it changes slightly. Not much. The average. But we will run that over the whole year. Then let's see what that implies. I also have tree cover here. It's I think it's also there's also default. If none, no grass will be assumed for the urban area. If none, it will determined by evaluation by the horizontal area of all context shade geometry that has true its vegetation property. It doesn't matter. So we can add a value here. 0.25, and we can do the same with the grass. It should be clear now what you can do here. There's a bit more. You can also use the buildings, as I said before. There's the terrain, the traffic parameters. You can construct a design day from your weather data, from your new weather data. You can write the Ladybug design days into standard design day file. You can create a custom e+weather data. This is basically, you can manual input your data. That's also interesting, and you can write an e+ file. You take this and it will just write a new file into a folder. Pretty cool. I have not looked into that. That's something I will do next time. It's the import the climate data from CSV file of annual data obtained from the National Oceanic and Atmospheric Administration database. At some point we all will also look into the horizontal infrared and the luminous efficacy. Please don't ask me yet what that means. I need to research. Oh yeah, and we also have the boundary layer parameters. Urban boundary layer is again, goes quite scientific. A number that represents the height in meters of the urban boundary layer during the daytime. This is the height to which the urban meteorological conditions are stable and representative of the overall urban area. Typically, this boundary layer height increases with the height of the buildings. The default is 1000 meters. Okay, so I need to read more about that. I just plugged it in just as an example on all the options you have to create like a very, very detailed alternative weather data to the one you downloaded. There's really just a slight difference, but we can run the whole year and let's see how that changes. No big changes. It's slightly less blue in some areas. It's probably a good sign, or maybe the original weather data is already quite typical for urban area. But yeah, let's look at the output here. Yeah, it's not that big of a change, I have to say. Let's try another weather data. It would be interesting to see something else. Madrid, maybe. Let's try Madrid. Yeah, here's you can see here's quite different already. It's very similar to Rome, where during the night it actually doesn't cool down that much, or in the morning. Overall, much more milder. As you can see here, it doesn't cool down really. Whereas here it would have been around 0 degree, where here it's almost like 4 degrees more. Let's check the average output. Yeah, it's 2 degrees warmer overall. I'll try to Madrid as well. Not Madrid, Paris. I'm interested how Paris looks like. Yeah, hey, this is pretty cool. I actually did not 100%, I was not 100% sure what I should expect from Dragonfly when I started with it. And now I completely get it. To have the ability to test your model, your design, and how it might affect the environment is pretty cool. And with that thinking, I want to actually go forward into my next videos where we hopefully start to look at real world scenarios and real projects. Maybe it's a housing project. I'm thinking of a housing project, and we probably start with something like analyzing the site surveys. We will talk about these things, and I'm pretty excited about it, and cannot wait. See you hopefully in the next videos. Oh yes, I know the Dragonfly portion energy, we haven't really looked at this. Probably in later videos. It is US based, and that's why it's less relevant for me. If somebody's really like saying, oh, we need to look at that, this is the most important thing in the world for my project, I will look at it at some point for sure and see how I can integrate it in my own kind of workflow. All right, with that note, see you in the next videos. Ciao.